Let's look into more examples. Now we are going to do Python web app deployment. So this tutorial introduces the key. This tutorial introduces the key concepts of Docker Compose whilst building a simple Python web application. The application uses the Flask framework and maintains a hit counter in Redis. So the concepts demonstrated here should be understandable even if you are not familiar with Python. So it's not that difficult to do this. So because I will give you the Python web application code, but here the main focus is how to use Docker Compose to run two containers together. That's what the main focus. So let's get our sticky note and Docker Compose example 1, that is Python web app deployment. So first we will begin with prerequisites. Prerequisites. So will Docker engine should be installed. Docker engine should be installed to Docker Compose binary file should be placed, or Docker Compose should be installed, whatever way you would like. 3, or else if you don't use either Docker engine or Docker Compose together, you can simply install Docker desktop, whichever way, or I'll put or, yeah, or Docker desktop. When you install Docker desktop, by default you will get a Docker Compose. So either way, so we have installed Docker engine and Docker Compose both. So let me underline this. So if you want to work with Docker Compose still, that's fine. But we are going with Docker engine and Docker Compose. That's what the actual way of doing in production or in operations of IT. So, and one more thing is, you note, you don't need to install Python or Redis, because we will do it through containers, as both are provided by Docker images. So let's write the steps that we are going to follow here. So prerequisites is done. So once prerequisites is done, so now procedure, this is a procedure. So in procedure, first step 1 is to define the application dependencies. So in this step 1, what we are going to do is, we are going to create a directory and we will write our web application. We'll create a directory, and inside that we are gonna write our Python web application. Once that is done, Then let's get into the step 2. Step 2 is to create a Docker file. That is, we have to write our Docker files, and once Docker file is written, then we will go for Docker compose. So that's step 2. Step 3 is to write or define the services in a compose file, which is YAML. We have done it for previous example and we will do it for this example also. Once it's all done, now it's time, the final step, it's time for us to build and run your app with compose. That's it. And final, once it's build and run, last step is validation. Make sure our application can be accessed through the public IP of the EC2 instance. So these are all the steps that we are going to do. So why to wait? Let's get into the serious business now. So let me go to my EC2 instance and we will begin our action. Yes, here it is, my EC2 instance. Yep. So clear the screen. Let me get into home, Ubuntu and ls. So let me create one directory, that's mkdir docker compose python, and it is flask or simply flask. Docker compose flask. Docker compose flask. So now it's time to do our step 1. Our step 1 is to define the application dependencies. Okay, that's our step 1. So let me create a directory in this. So mkdir. Okay, but before that, let me enter into the docker compose and flask. Yeah, so let's create a directory for this project, that is mkdir. I'm gonna say flask web app. So cd, yes. Now let's write our web application. Let's create a file called app.py in our project directory. So let's write that. So let's import, as it is a Python code, let's import time module first, and after that we also import Redis. So Redis has been imported. Now let's also bring from flask library, import flask module, capital F. Okay, let's begin. Let's define our app. So app, we are defining our app using this. So using flask, and so name and catchy. So redis and host is Redis again. Here Redis is going to serve our flask application, so that's why host I am mentioning Redis only, and port is 6379. That's a default port 6379 for this Redis service. So that's why I'm going to go with that only. So that's our cache. So now let's define the function that this app is going to do. So define. So the function is get click count. That's the function name, click count. Done. And inside that retries is 5 while true. Try that again and return cache dot increment of clicks. And accept redis dot exceptions dot exceptions dot connection exceptions dot connection error as exe. Then if retries equal to 0, that's conditional operator equal conditional operator, then rise exe. That's what we want here. And so retries again, if it is equal to 1, time dot sleep 0.5. Then let's put two more lines of pieces of code here. So we're gonna route this app. For that, what we're gonna do is at the rate of app to define. So at the rate of app dot route. So we want to attach that route and using forward slash. This is the root, basically home route. So now we are attaching a function that is def, and this is chant. What I want to count, def here it is. That's the problem. There is the issue here. Yeah. Def, and then chant is the function that we are defining. Yeah. So count, and what's the name we have given? Here it is, get click count. Let me copy this exactly. So copy and paste it here. Function, and what do you want to return? Return Hare Krishna. So I have been chanted these many times. These many times, and I'll begin a new line. Okay. So let me format this using format count. We just want to count it. And that's it. This is our piece of code. Let me save this. WQ. So let me do cat of app.py, and here is our piece of code. Yes. So the first step has been completed. In this example, in this exercise, Redis is the host name of the Redis container on the application's network. So we use the default port for Redis, that is 6379. So now let's create another file called requirements require requirements.txt in our project directory, and we will write the requirements that is to be fulfilled before we run our application. So that is, first one, flask should be installed using pip install flask, and similarly Redis module or library should also be brought into the system. So that's it. These are the two, more than enough for us at this moment. Let me save and quit. Now let us see how many files we have. We have app.py requirements.txt. With that, the first step has been successfully executed, that is define the application dependencies. Now let's create a Docker file. That's our second step. Create a Docker file. Okay, so here let's write vim docker file. So the Docker file is used to build a Docker image. The image contains all the dependencies the Python application requires, including Python itself. So in our project directory, we will create a file with a name Docker file. Let's do that. So let's begin our code. So obviously we require a base image, that is from Python 3.7 tag alpine. Then we have work there, and work there is /code. That's it. Then environment env. So flask app is equals to app.py. That's what we have given the name, and another environment variable, this time flask run host. So this is inside the container. Let's give the same flask run host. It is 0.0.0.0. Okay. Then it's time to run some commands. Capital run. So flask run host has been done. Now it's time to run apk and add no cache gcc musl dev and linux headers. Now it's time to copy the requirements.txt into the container from host machine. So requirements, okay, let me save it till here and copy the name exactly. If there is a small mistake, it will, okay, we have requirements.txt. Exactly, we'll copy this. Yeah. Copy the requirements.txt from present working directory in host machine to the work there, that is /code of container. Okay. So then after that, it's time to run again Linux commands that run, and now we need to install all the libraries that we have mentioned in the requirements.txt. For that we require pip to come into the action. So we'll say pip install option R recursive, and it's a requirements.txt which will be copied into the container. Then after that, let's expose this to 5000 of port 5000 of the container, and after that copy everything whatever there in the present working directory of the host machine to the work dir, that is / code of the container. Sorry, one more dot. Let's run a final command, that cmd, which takes argument as well as a command as well as the argument. The command we are going to give is flask flask, and that's command. Argument is a run. That's it. When you spin our container, it's the flask and run command will be executed, and our application should up and running. Let's save and quit it. WQ. So here just let me do cat and docker file, and let me quickly go through it. I will make it a little bigger so that it will be much clearer for you. Yeah, from here to here I will mark it. Yeah, now you see that. I'll just go through it quickly. So build, this tells what this docker file tells docker to build an image starting with the python 3.7 image, and set the working directory to / code, and set environment variables used by the flask command. Then install gcc and other dependencies such as musl div and linux headers, and copy the requirements.txt and install the python dependencies that are required or that are mentioned inside the requirements.txt. And finally here add metadata to the image to describe that the container is listening to 5000 port, and copy the current directory in the host machine project directory to the work dir inside the image, and set the default command for the container to flask run. So successfully we have written our docker file. So now it's time to jump into the third step. Before that, let's cross it. The second step, that is create a docker file, has been done. Now the third step, step 3, is to define the services in a docker compose file. So let me attach the comment here. The step 3 is to define the services in compose file. So now let's begin that. Let's create a file called docker compose.aml. Okay, compose.aml, and let's attach all the services which are part of this. So this is YAML file. This is very important. With this file, the Docker Compose spins all our containers or builds all our containers. But here in previous example, we have directly taken the, we have directly built, spun our containers from the built image. But this time we are going to build one image with this file, and we are going to get one image from the Docker Hub. Okay, let's begin. Let's begin with version. Okay. Just a minute. Yeah. Docker compose YAML, correct. So I insert mode and version. It's 3.0 9 or 2 point after version the after 2.1 anything you can use. So now let's begin services. First services, this is the main key services, and below which we have two services, that's the two uh, key pairs, two key pairs basically. So let me add that. The first one is web, that's the name I'm gonna give for the web, and this web application. So this service will build, I think we are not getting a proper indentation here. I don't think it's a good idea to write here. So let me write it somewhere. Yeah, here I will write that, and then we will copy paste it. Okay. So version, yeah, it's a 3.9. Okay. So after version, let's define our services. And services we have two, that's web build. So I'll just give dot because it's presented in our directory. So I would give the dot, and ports. So port mapping is pretty simple. So ports we are going to give only one, and it is map 8000 with 5000. That's where our application is going to be exposed. Done. Let's add one more service, that is redis, and build. No, here we're gonna use image, so that is redis alpine. That's it. This is our file. So redis alpine. I hope everything is fine. So yeah, let's paste it here. Yeah, this is the correct way. Yeah, I hope. Let's WQ save and quit and click enter. So this compose file, so let me do the cat of docker compose yaml, and let me zoom it more, and here you could see the our docker compose file. Now let's cross check it. Let's go through it one more time. This compose file defines two services. One is web and other one is redis. The web service uses an image that's built from the docker file in the current directory or present working directory. It then binds the container and the host machine to the exposed port 8000. So this example service uses the default port for the Flask web server. And we have the second, the Redis service uses a public Redis image pulled from the Docker Hub registry. So now let's get into the fourth step. But before that, we are going to mark this. So the fourth step for us here is to build and run your app with Docker Compose. This is now we are doing the fourth step. So here we have to build and run our app with Docker Compose. So we should be in our project directory. Let's check. Yes, we are inside our project directory. We have Docker file, we have app.py, Docker Compose YAML, requirements.txt, everything by and large we have. So now it's time to run our application using Docker Compose up. So Docker Compose and space up and click enter and see what's gonna happen. So Compose pulls a Redis image, builds an image for your code and starts the services you defined. So in this case, the code is statically copied into the image at build time. And there are some warnings. This is a development server. Do not use it in a production deployment. Use a production whiskey server instead. That's correct. That's okay. That's fine. So press Ctrl C to quit it. So our application is running at this service at this point 127.00.1 at anyway we have mapped it with this thing. So let's get into our instance, and I think it's 8,000. Here it is. Let me zoom it more, zoom it more, zoom it more, and here it is. Hare Krishna. I have been chanted this many times. Okay, this function hasn't been added. Okay, so we have to do some modification here. Okay, let me do the change. I think some piece of code is missing there. I will cross check it. Okay, let's get into the server now. Do Control C. So it's killing the containers. It's stopping the containers because it's running on screen, not background. It's not running on background, but that's okay. So let's do vim app.py. Yeah, this is the mistake. You see that? Okay, while explaining, we do some this kind of mistakes, but that's okay. That we can do change it because this is not fun. Here we have to use curly braces. That's how Python works. So now WQ, and let's clear the screen and run the app again. But before that, let me check the Docker PS. No container, Docker PS option A. Yes, you have two containers. One is flask web app web1, flask web app redis 2. Let me do the docker compose down so that it all will be deleted. So docker compose down. So removed. Simple. One command, all done. Okay. Let me do the docker ps option here. One gone, all gone. So now let's do the docker compose up one more time. One more time. Yes, it's done. Let's get into the server and refresh it. Okay. Got it. So I'll do the docker compose down, and we have to stop. Let me stop this one first. Yeah, cancel. So let me cross check. Okay, there is nothing to app.py. That's the only problem. So image, is it using? No, it's using docker build file. So not, it is not an issue. So docker compose down. So all the containers has been removed. Now let me do the docker compose up. Let it be started. So it started, and let me cross check now. Oh, still it's saying the same code. Did I save it or not? Yes. Okay, stopping that. Yeah. Docker compose down. Docker images. Oh, there are a lot of images. That's okay. What I'm gonna do is I'll remove Docker RMI flask. Yeah, that's done. Now let me check vim and app.py. Okay, it's been changed. Yeah, it's been changed. Now let's, okay, got it. Now let's run it, because the existing image it has directly used it. Now it's gonna build the image. Okay, it has to rebuild flask web app redis 1, and I hope, yes, that's the issue, because it's reusing the image again and again. So that's the reason. So I have removed the image, the existing image, and then I have recreated the image and all set. Okay, Hare Krishna. I have been chanted 2 times, again 3 times, 4 times, 5 times. It's a counter. You can use this counter to count your chanting. This would be very useful for the Hare Krishna devotees or any devotee, whether whomever you pray, it could be Jesus or whatever it could be. You can use this counter to count your chanting, how many times you have done it. So this is useful for you. So we have done it using, see, you just said Hare Krishna, count, 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 count. You can just click on, click on, click on. It will count the number of times you have chanted. And this is how you can use our, and here you can see that get http that requests every time it's updating. So now just look into the, we'll close this, we have seen enough. Or if you want to do a bit of experiment, let me do one more time. 13, 14, 15, 16, 17, 18, 19, 20, 25. It will count, it will keep on count, keep on count. It will go till 108, because 108 is special for us. So we do 108 times for one round. So one round is done. So let me close it, and let me list the images using Docker Compose, and let's also inspect one by one. So let me use Docker Compose commands only, not Docker Compose, and say ls to list the images. So Docker Compose ls, there is name status config files, no images. Docker Compose ls. So this time we are gonna say, okay, so Docker image, and here is that flask web app. 2 minutes ago it's been created, and redis is another image. So we can inspect these images using our tag and an id. So let's if you want, you can do that. In this case I'm not doing, I'm going to tag these images properly, and then I will push it into my Docker hub. So Docker tag, it's a flask, and then name I'm going to give is cube flask web, and v1. So Docker image ls, and this is the one. So let me push this first. Docker login succeeded. So Docker push, and it's a kubecheren flask web app and version 1. So it's getting pushed. Once it is done, we will push the redis also, redis alpine, as it is redis alpine. Okay, that's done. So now what we're gonna do is we will Docker tag one more image, that is Redis Alpine and cube Charon Redis Alpine, and we are going to push that also. Okay, it's been tagged. Now it's time to push Redis, sorry, cube Charon Redis Alpine. Yeah, so we are pushing. Once the pushing is done, let's cross check that whether the push has been happened or not. And here it is. Here are my repositories. Let me refresh it, and you should be able to see the images here in our, here it is, Kupcher and Redis and Kupcher and Flask with tags. So now we have seen enough. So we will do Docker compose down so that all the container will be released or deleted, stopped and deleted and removed completely. So Docker compose down. That's it, removed. All the containers are removed. Let me cross check Docker PS option A, all gone. So clear the screen and let us get into this. So step 4 is done, step 5 is also done. Let me underline. So let's get into our PPT. So Python app web deployment is successfully done, but I'm gonna add more masala to this, or I'm gonna add more fun to it. Whichever way you want, you can take it. It's not an issue. So here what I'm gonna do is the additional task that I want to attach here is for the same exercise, that is sub exercise. So we want to attach bind mount to the project, to this project. So what I'm gonna do is, here I am gonna do two steps. One is everything remains same, nothing we are going to change. Step 1, we will edit the Docker compose file. So what I will do is, in spite of taking images from official Docker Hub, I'm going to take from my Docker Hub repositories. Okay, so both the images, so images will be used from my repository. Okay, so let me get the images names first. One is flask, and here is see all, and you will get it. So name, and where is that? And another image, get to the repository, it's a Redis, click on see all and copy this and paste it here. So these are the two images I'm gonna use, and then we also do the step 2 in this is to edit the compose file to add a bind mount. Okay, so let's do that. Why to waste our time? So let me do vim docker compose yaml. Here is the file. So here first I will do this in spite of build. I would say image, and image name I'm gonna give, what's the image name? So image name is this, exactly with tag. So I've copied it, I'm gonna paste it here now. That's it. And now I'm gonna add bind mount volumes to this. So after ports, let's create a one more object, that is volumes. That's it. And I'm a little worried whether we'll get it exactly or not. Yeah, hope. Yes. Then dot present working directory should be mapped as a volume as a bind mount to the code. So whatever is there inside this code should be copied to present working directory, or whatever is there in present working directory should be copied to the code directory inside the Docker image. Okay, sometimes I say inside the container. You can you I interchangeably use that, but fundamentally it is inside the image, because container is a lightweight machine and image is the heavyweight one, which consists of all the directories, and container is just a machine which runs. It's a process. Container is just a process. Image is the one which consists of everything, which stores the data, which stores the information, which stores the utilities, which stores the services, which stores the applications. Okay, so we have attached our bind mount. So now we will add one more thing, that's a debug. So environment, let me go little back, indentation. So it's flask underscore debug and put it true. Fine. Oh, we have to change the redis image name also. So let me copy the redis image name and paste it here. So that's here, we'll get it. Yes, so we have done all the changes. Now it's time to do our experiments. So let me do the cat before we go for that. So here you could see the, I will mark it to, so that you can have a clear picture of what is happening. You see that this is our new Docker Compose YAML file, an updated Docker Compose YAML file. In this, the new volumes key mounts the project direct, the current directory or present working directory on the host to the forward slash code inside the container or inside the image. Take it interchangeably, allowing you to modify the code on the fly, allowing you to modify the code on the fly whenever you want. You can do that without having to rebuild the image. You just do the code changes. And before, what we have done a lot of steps to do the modifications on the code, but this time without that you can actually do the modification. Let's do that, not to worry at all. So the environment key here, the second one, sets the flask debug environment variable, which tells flask run the development mode and reload the code on change. So this mode should only be used in development, not for the production. Okay, this is just an experiment. So now let's attach our third step. So this has also been successfully done. Now the final step here is to rebuild and run the app with Compose. That's the final step. Let me, yeah. So clear the screen first. So from our project directory, we will do a Docker Compose, because that's where we have our compose.yaml file. And let's say up to build the app with the updated compose file and run it. Let's click it. So all done. It's successfully running, but okay, this time we got restarting with state. Debugger is also active because it's a in production environment, it's in development environment. We got the debugger pin also. So let me go up and see. So from where this got images, I think it's used Flask web app Redis one directly. Okay. Okay, let's refresh it and see. Here, Yes, the image has been pulled. That means it used our images only. So now let me refresh it and you see that it's one times. It's fresh app. Okay. So let me refresh it. Okay. More. Yep. So that's it. We have successfully built it using this also. Let me do the control C and let's look into the let's update the application now. The next step is to update the application. So here, so this has been successfully demonstrated. Now it's time to update the application because we have used the mounts, correct? We have used the bind mounts, so that's the reason we are gonna update this application. So that's a step 4. Update the application. So here, because the application code is now mounted into the container using a volume, that's a bind mount, you can make changes to its code and see that we can see the changes instantly without having to rebuild the image. That is the power of bind mounts. That's the power of volume, but that's the power of bind mounts and volume mounts. So let's change the greeting in app.py. So instead of using Hare Krishna, just we will say Hare Krishna from Docker. Till now I'm saying, now I'll say Hare Krishna from Docker and we'll see what's gonna happen. Okay, let's yeah, you got the PyCache? You see that? You see that? You got the PyCache? So PyCache, it's the there you will find the .pyc, the compiler code of Python. Let me get into that and show, but this is not the Python class, but still I'll show it to you. Okay, here is that .pyc. Of course, this is not Python class. If you want to have more information on that, kindly, I beg you to watch my intuitive Python course because I have explained it in such a detailed way and simplest way, detailed and very simple way to make you understand. So kindly watch that. Okay, so let me get into the project directory and here is that let us make a changes to our app. Okay, and we'll see what's going to happen. Let's see the magic this time. Here is that. Let me click I and scroll. Yep, here. Hare Krishna and from Docker. From Docker and Docker have been up has been chanted this many times. Let's we are sorry, I'm making Docker to chant Hare Krishna also. That's brilliant. So let me do W and Q and save and quit it. Let's do nothing other than getting into the browser and checking that. It's taking some time. No, it took a lot of time and it's gone. Ah, okay, got it. It's not up because uh, we have stopped it, nah? We have stopped the container here. So let's do that. So Docker refresh the app in the browser. So the Docker greeting updated, the counter should still be incrementing. Okay, the here our app we have stopped it. So let's rerun it. Docker compose up. Yep. You see this? But it's running from 21. It has not been started from the scratch. That's what I'm saying. Okay? These are the changes. This is how you can apply your code, whatever changes you want to do directly without stopping or without removing your image. You can do the changes directly to your image. That's the power of mounts. That's the power of mounts. That's the power of mounts. As a developer, the developer only knows the benefit that he gets from that mounts. You see that? I will keep on doing that. I will make Docker to chant 108 times. 108 times. So that Docker will keep on growing in. Just kidding. Just to have some fun. Nothing else. Okay. Don't take it seriously. Okay. So that's it. So we have updated the application also. So if you want, we can experiment with some other commands if we want. That's all up to us. So I will do underline to this also. So that's it. So we can run this similarly using Docker Compose upd. So if you want to run our services in the background, you can pass the d flag, that's detached mode, to Docker Compose up and use the Docker Compose PS to see what is currently running. This is what we will do, and we'll do some changes and we'll finally experiment that. So let me get into the control. Let me do that. Let me do the Docker Compose down first completely. Let me make it down. Done. All has been, containers has been removed. Now we will do Docker Compose up in detached mode. That's D. So you see that only the containers has been created, that you can see. Now let me do Docker Compose PS, and here is our containers which are running. You can see the port mapping 8000 to the 5000. So let me get to the 8000 and copy this and use our existing, yeah, see, Hare Krishna from Docker has been chanted 10 times, 2 times, 3 times, 4 times. That's fine. It's been new built. So now we will do modification to our piece of code, and so vim app.py. So here I'm gonna say Ram Ram from Docker. This is from North. Okay. So let me do the change and refresh it, and we gonna see what. That's it. That's the magic. So that's how it works, without touching the image, without touching the container, without doing stopping or updating or up down, nothing. Just update the code in your host machine. The code has been copied into the image or container, and you could see that reflected in our application. So that's how a bind mounts helps us. So finally, all done. So let's close it. Let's do Docker Compose stop. So let's do Docker Compose stop. So all the containers has been stopped, and we want to remove those volumes also. So that's the reason I would say Docker Compose down option volumes. So volumes also has been removed. So everything is clear. So that's it for now. We have, so far, what we have done is too much. Okay, I hope you are seriously following this video, because it's pretty much useful. So from writing a directory, let me repeat this. We have defined the application and dependencies, then created a directory, and inside that we have written our Python web application, then we have created a Docker file, then we have defined our services in a Compose file, then we have built and run our app with Compose, then we have validated. Then after that, we wanted to attach the bind mounts to the project, so we attached the bind mount to the project using do following changes. Images will be, so we have used our own images from our repository in spite of depending on the Docker Hub, official Docker Hub images. Then we have attached the bind mount to the Docker Compose file, then we have rebuilt it and we have run that app with Docker Compose, and then we have run our doc application using Docker Compose up in detached mode. That's option D. Then we have done some changes to our code, and automatically it got the application got updated. So that is the power of mounts. Hence, proven.